everyone. Thank you for joining us again. After lunch now, A.J.Fisher is going to talk to us about ridiculously exciting things. I'm really keen. AJ is a senior analytical engineer at Synergy in Perth. They literally keep the lights on doing all sorts of electrical stuff. And you are a self-described dataholic, which I think a few of us in the room perhaps can relate to. AJ, thank you very much.
And thank you so much, Nikki. I really appreciate that. Welcome, everyone, to Build Your Own IoT, fun with Python and Raspberry Pi. Thank you so much for having me today. I am incredibly excited to be here, and I hope we can have some fun. So, a little bit about what we'll be talking about today. So we'll start the talk with an introduction to the growing importance of solar energy in Australia. Then we are going to build out a live data system, meaning we are going to be collecting data every single 1 second and working with that data in the internet or in the cloud. So before we do that, though, we'll need to talk about the hardware required. And then at the end of the talk, we'll talk about how we can build out this live data pipeline into a full IoT application. So the focus of this talk is not on building an entire application, it's about a live data pipeline that you can do everything in using Python. And then at the end, we'll wrap things up and hopefully have about 5 minutes for questions. So I'll start with the question, why should you care? Well, why should you care? I'd like to talk a little bit about the situation in the city I'm living in at the moment in Perth, over in West Australia. And it is currently estimated that 1 in 3 homes in the Perth metro area currently have solar PV installed on the roofs of their homes, which is amazing. And just to give you a figure for how much solar energy was generated in calendar year 2023, taking some numbers from the market operator and AMO and running a small calculation on that, it comes out to a little bit over 3,000 gigawatt hours. Now, you don't need to know what a gigawatt hour is, but I want to compare that to a traditional coal plant. And here I'm going to compare that to the Muja power station in Collie, West Australia, and again, just looking at 1 year of generation. And that comes out to about 3,000 gigawatt hours of electricity. So how amazing is that, that already today there is enough rooftop solar in the Perth metro area to generate as much electricity as a coal plant on an annual basis. That is absolutely bloody awesome. And the market operator, AMO, is predicting that the amount of installed solar capacity is actually going to over double in the next 10 years to 2034. And with all this installed rooftop solar, you can imagine there's a lot of data involved, and the government of West Australia is investing in looking at how we can best invest in these rooftop solar panels and utilize that in our electrical grid. So in terms of what we're going to be building today, we're essentially going to be building a live data system for a micro-scale version of the following, where we can have solar panels all over Australia, whether in Perth or Sydney or Brisbane or whatever city you live in. And we can also have multiple data consumers. So here, just using a made-up example of a central Melbourne control center, and perhaps our friend Alice up in Darwin, who's going to be using this data as well. And we're going to be using a very special and very exciting piece of software to help facilitate the movement of this data to our downstream consumers, and that software is called Apache Kafka. So we're going to be building a data pipeline to move the data from the data producers to the data consumers. And a couple messages I want to share with the audience. So hardware is not typically seen as being in the Python realm. Like people typically assume that you need to know C or C++ to work with hardware, but I'm here today to tell you that with a Raspberry Pi, you can do this all in Python. And after the talk today, I encourage everyone in the room to go out and try to build their own IoT and or Raspberry Pi application. So rather than doing a deep dive into any one topic today, we'll be looking at a whole range of topics, some of which I hope will interest you, and maybe you'll go out after the talk and learn a bit more. But most importantly, and above all else, the one thing I want you to walk away with after the talk today is being able to go home to collect your very own Raspberry Pi data. Okay, let's talk hardware. So with any IoT application, you first require some kind of sensor. And the sensor we're going to use today is a little mini 1.5 volt solar panel. So this is essentially a light sensor, but it's going to tell us about the light in the room with voltage. And that panel costs roughly about $20 at your local electronics shop. And the next piece of equipment that we're going to use is this thing called an analog to digital converter, or ADC. And what that's going to do is the little mini solar panel produces an analog signal, and that nice waveform that you can see on the left side of the ADC. And what this little piece of equipment is going to do, this little ADC, this is going to translate that signal into a digital signal that can be used by a computer. And of course, to introduce the rock star of this project, we have our Raspberry Pi, which is a single board computer, here acting as a local server. Now, the Raspberry Pi comes in at about $133. Understandably, that may not be in everyone's budget. If not, I do encourage you also to look at the Raspberry Pi Pico, which comes out at $6. Now, with the Raspberry Pi Pico, you just need to program that in MicroPython rather than just base Python, which we'll use with the Raspberry Pi. And fully set up, it looks a little bit something like this. Starting at the bottom of the screen, we have our little mini solar panel connected to our ADC, and then that is being read into the I2C pins on the Raspberry Pi. So the really fun thing about hardware is we can actually do a bit of a show and tell. So we will now pass around these three items, and you can take a look. So we'll start with the Raspberry Pi and the pinout configuration. And we also have the mini solar panel and ADC. All right, so we have our hardware set up. And the first thing we need to do now is we need to read a voltage value from the ADC and the solar panel into our Raspberry Pi. And here you might be wondering, okay, is it time to bust out the KNRC book? It's a great book, a great language, but the answer is nope, you can use pure Python. So the amazing thing here is that the manufacturer of the ADC, Adafruit, has actually produced their own Python library that allows us to read values into the Pi. And I want to give you a number, that number being 9. So with just 9 lines of code, excluding our import statements, we can start reading values into the Pi in a loop. Even less is required if you just want to read a single value, but we'll be reading them in a loop and getting values every single 1 second. So just to show you a little bit of what that looks like, I have a conceptual map on the left side of the screen and the code on the right side of the screen. So what we need to do is we'll be importing our libraries for Adafruit, and then a couple libraries, this board and bus IO, to help us set up the I2C and ADC. So with that, we now have 3 lines of code. And what these 3 lines of code are designed to do are They're going to help us set up the I2C bus and the ADC, but really what we want to get out of this is we want to get the channel on the ADC. So essentially, just asking the ADC, where are we going to read values from? And this can be a little bit tricky, especially doing this for the first time. So I do recommend looking at the Adafruit GitHub, where they have all of this code ready to go, and you can start playing with that. But then, once we have the ADC channel all set up, ready to go, we can then just set up an infinite loop and just read those values using the voltage attribute of the channel. And then we have a 1 second sleep statement. It'll read in a lot quicker than that if you don't put that in, but we only want to get values every single 1 second. And then later we can clean it up a bit. So that's great, but the next question is, what does that data actually look like? We have some voltage values coming in, and there's two ways that you can work with this data and eventually send this to the internet. So the easier way is to just have a single decimal or float value, and keeping in mind that these are time-stamped values. So each value that you get is going to be associated with a certain point in time. And that ends up looking a bit something like this at the end of the day, where you have the timestamp, and then you just have your single number for the voltage. And I just wanted to mention one thing as well. On that mini solar panel, 1.5 volts. So at the peak of the day, when it's very sunny, we expect to see 1.5 volts. When it's dark outside, expect to see 0 volts. But another way that we see this data being flown around in real life is as JSON messages. So if you're new to Python, you can kind of imagine this as like a little dictionary. But what I've done here is we're measuring the voltage every 1 second, and then I've padded this with some additional dummy data to create these JSON messages. And what that looks like then is instead of every 1 second we send a decimal number, we then send these little messages every 1 second. Okay, now we need to talk about Apache Kafka. So Apache Kafka is a cloud-based data streaming platform that's going to help us handle many data producers and many data consumers in live time. So there will be a little bit of latency over that Kafka platform, but essentially those downstream consumers should be able to use that data in nearly real time as that data is produced. So just to give a little bit of an analogy here, I want you to pretend that these messages being sent are like mail. And I'm going to simplify Apache Kafka a little bit here, but you can kind of sort of think of Apache Kafka as like a big cloud-based conveyor belt that's going to help get the data from our local machines, wherever they are in Australia, to our downstream apps in different places in Australia. Now, unfortunately, we can't just teleport our mail from our home to the local Ozpost warehouse. So I want to introduce another term here on how we're going to do that. We need a special client called a producer. And the producers are essentially the mail trucks that are going to operate every single 1 second, delivering those messages to that central data platform. Now, we need a way as well to get the data from Apache Kafka to the downstream apps. And you might assume again that these are going to be more trucks, essentially, delivering that mail. But it's a little bit different in Apache Kafka, and rather than trucks, the analogy I'll use here is more people with barcode scanners. So it's the same messages, but people going along, walking along those messages, and scanning the messages as they come in. But not really delivering those, not taking them out, just scanning them and leaving them in as you go. Now, in terms of actual implementation, I do want to talk about one of the elephants in the room in the software community, which is the cloud can sometimes be a bit overwhelming, especially for beginners. So with this project, I wanted to choose a service that was a bit more user-friendly, perhaps, and as well was a bit on the more affordable side. So to that point, I have chosen Confluent Cloud for this. So rather than needing to set up some complex infrastructure, you just go to the website. They have a 30-day free trial, and then you can set up a server by following these guided forms. So it'll ask you some questions. You fill in your information, and it'll set up the server. It'll set up the Kafka cluster for you. And really, what we want to get out of this is this configuration dictionary that we can give to our Python program. So essentially, helping to tell the program where is this data system located in the internet. It'll give us some credentials, so not just everyone can access our data, and we can use that moving forward. So here's what we have so far. And again, we need to think about that producer, so the trucks delivering that mail from our local machine, and then we also need a downstream consumer. And another reason I really like Confluent is they actually have a free course on their website. So this Apache Kafka for Python developers course. And in particular, they have provided an incredibly convenient library, the Confluent Kafka Python library, which we're going to be using for the rest of the presentation here. And this is going to act as the client, again, to deliver those messages. So just wanted to show you a bit of the code here, just keeping in mind that I've only shown the main ideas, not all of the helper functions and all that. But essentially, what that code is going to look like is we're going to be using the Confluent Kafka library, and we're going to be using the producer class. From there, what we need to do is we're going to feed that producer the dictionary, that setup dictionary that we got in the previous step. And as well, we're going to tell it a little bit more information, where to look in that Kafka data system and where to put that data. So we're going to give it this thing called a topic and a key. So from there, we get our ADC set up and ready to go. And essentially, we modify that infinite loop that we had before, reading values from the Raspberry Pi. So we're still reading values from the Pi in a loop, but we add a couple additional steps. And one of the most important things here is we first have to turn the data into bytes before we send that to the internet. Now, the Confluent Kafka library does have some convenience functions that you can use for that. Here, I've used the struct.pack function. I was having a bit of trouble getting the built-in function working on the Pi, but it still does the same thing. It converts it into bytes, and then we use the produce method on that producer instance, and that will help us deliver those messages to our Kafka cluster. And again, we'll have it sleep for 1 second in between sending things to the cloud. Awesome. So once we have that data in our Kafka data system, we can now interact with that data in 2 ways. We can interact with that data in real time, or we can save that data for a longer-term analysis. So say, for example, we can come back in a week, and we can analyze that whole week worth of data. So just wanted to mention another nice feature of using this Confluent Cloud, which is they have no-code connectors through Kafka Connect. And what I mean by that is you can actually sync your data from that Kafka cluster into your favorite databases just by configuring those databases and telling it where to go. No Python code required for that. So here I've just used Elastic and Snowflake, just the easiest 2 to set up. But you could also use, I believe, other options as well, such as MongoDB. Shout out to our Platinum sponsor. So you can sync that data into an actual database, analyze it later on, but we still want to analyze that data in real time as well. We want that data for our central Melbourne control center. And we're going to do that with this thing called a Kafka consumer. Again, going back to that mail analogy, the person with the barcode scanner walking along and getting the data out of those objects. And again, remembering that the data in Kafka is coming in as bytes. So we need to work with that byte data. So similar to the producer, we're going to use the Confluent Kafka library again and importing a consumer this time instead of a producer. And we're going to use this double deserializer, this thing here, to help us turn those bytes back into a decimal value that we can use in our application. So similar to the producer again, we give it a configuration dictionary. We tell the consumer where to go. But a little bit differently, we actually subscribe that consumer to the topic. So we tell that person with the barcode, okay, you're specifically going to be in this part of the data system, essentially. And then what we do is similar to the producer, we set up an infinite loop. Every second, we pull that consumer to see if there's an event. And if there's an event, we then deserialize that double, so that decimal number is bytes, back to a decimal number that we can use in our application. And really, that's kind of it. It's what I'd like to say on this is, yes, there's a little bit of code that's hidden here, but my message to the crowd is, this isn't thousands of lines of code. So with just a couple slides worth of code, you can start getting up and running with Apache Kafka and start flowing your data through the internet. And really, that's kind of it. We have now created a fully functioning live data pipeline, where on the left, we are getting values every single 1 second, voltage values. We're sending those to the cloud. And then not only are we storing that value in multiple databases for later analysis, but we can actually work with that data in real time. So you could have like an app on your phone where every single second or every single couple seconds, that value is refreshing on some sort of app, which is really exciting. And so essentially, we have built out something like this. Now, for today's presentation, we've just used a single solar panel and one downstream consumer, but Apache Kafka is excellent at handling multiple producers and consumers. So with what we've built so far, it would be fairly straightforward to add more solar panels using this same type of methodology, and then you can also have more downstream consumers consuming that data. And from there, we can add a couple of cherries on top. One of my favorites being the Azure Key Vault to help store some of our API secrets. And if you've worked with electronics before, you'll know that voltage isn't necessarily everything. Watts or watt hours might be a little bit more interesting for our purposes. So just wanted to talk briefly, just a couple minutes, on how we can now build out this data pipeline into a full IoT app. So here's what we have so far, where we have our essentially a local Perth panel, a local Perth server, and then we're sending that to the cloud for use somewhere else. So what if we added an additional Raspberry Pi or an additional server where we had multiple solar panels producing to that central server, all using Confluent Cloud or Apache Kafka? From there, we can add this thing I'm going to call an actuator. And in particular here, we're going to use this thing called a variable resistance potentiometer. Now, that sounds like a very complex instrument, but what that is going to do is it's going to allow us to adjust the resistance in our circuit and give it a set point. So meaning if we want to curtail our solar, if we're seeing too much production, we can raise how much resistance is in that circuit and curtail that production. And then from there, we can use Django to send a value for that set point on the resistance in that circuit, or any of these circuits. You can imagine any of these different circuits having these variable resistance potentiometers, and we can use this Django interface in Python to help us set those set points. So that brings us to the end of the presentation today. And in conclusion, the importance of solar energy continues to grow in Australia, and with that comes a lot of importance around data, and in particular, live streaming data. So today we had a lot of fun building out that live data pipeline, and we learned that anyone can build one just using Python. You don't need to know C or C++. And although like Apache Kafka is typically associated with Java, you don't need to know Java to start working with Apache Kafka, which is great. And as well, again, I want to encourage everyone in the room to, after you leave the talk today, to go out and investigate these topics a little bit more. Lots of fun things to learn, lots we didn't cover today. And as well, try to build out your own IoT and or Raspberry Pi project. But most importantly, and above all else, my conclusion for today is Python rules. So thank you so much. We'll now take questions. We'll now have some questions.
I think we've got time for one question.
Okay,
quickly.
yeah.
Sorry, we were a little late to start.
Oh, sorry.
No, here we go. Yeah.
Hi, great talk, by the way.
Yeah, thank you.
I just had a question, like, could we use something like an MQTT broker or an MQTT client instead of using Apache Kafka here in this use case?
I would need to have a think. For a simple use case like this, I'd want to take that one offline, but potentially, because this is a fairly simple application, but as we get more solar panels and as we get more downstream consumers, then I'd want to be using Apache Kafka just for that. Again, just for that, in the presentation called it like the barcode scanners, but just how the consumers work downstream. It's for multiple downstream consumers, it just tends to, my personal experience is I like it a lot more than just like a messaging queue. Yep. Yeah.
I'll interpret that as general agreement and another outrageous round of applause. Thank you so much, AJ.
Thank you.
Enjoy this spectacular mug. Thank you.
Yeah, cheers.